Okay, in this section we introduce trig identities. Well, we introduce them again, I guess, and we start actually working with them as identities. So we start with the one that we already know, sine squared plus cosine squared equals 1. Okay, that comes from the unit circle, x squared plus y squared equals 1. And we remember how to get those into other forms. So remember, we can take sine squared plus cosine squared equals 1. We could divide them all by sine squared. So if we divide through the equation by sine squared, we would get 1 plus cosine over sine is cotangent, and then 1 over sine is cosecant, so that would be cosecant squared. Okay, so we can take our identity that we already know, and we could get one that looks like this. Okay, and then we could also do sine squared plus cosine squared equals 1. We could divide all of it by cosine squared. So let's see what happens when we do that. Okay, so we get this is now tangent plus 1 equals secant squared. Okay, so now we have 3 trig identities just based off of this first one. And if you ever forget them, it's really easy to figure them out. You just divide by sine squared, cosine squared, and see what you have left. Okay, so let's look at how we can use these kind of identities to work with trig functions. So let's say that we want to find an expression for tangent theta in terms of cosine theta. Now, sometimes it takes a little bit of playing around with these to find the one that you really want, because like we've seen before, there are different ways to do these problems, and they all mean the same thing. They all get the same answer, just looking at it in a different way. So we've got to figure out how to get from tangent to cosine, and there's 2 things that we know about tangent so far. We know that tangent theta is equal to sine over cosine. And we know this one that we just found down here, tangent squared theta plus 1 equals secant squared theta. Okay, so which one is going to help us? Well, this one we have cosine, but we don't have anything to do with sine yet. Okay, we could use this over here to get sine in terms of cosine. Okay, so that's one way to do this. Or we could do this one, and remember that secant is the reciprocal of cosine, and get an answer that way. So these are the 2 things that we know about tangent, and we could get both of them in terms of cosine with a little bit of effort. All right, so let's try this one. So we need to get rid of the sine. We've got to get rid of sine. So what can we do with it? We can take this one and solve for sine. Sine squared theta is equal to 1 minus cosine squared theta. Okay, that's a similar identity, a rewriting of it. And if we take the square root, we would have sine theta is equal to 1 minus cosine squared theta. Okay, so we could rewrite this as 1 minus cosine squared theta over cosine theta. Okay, so that's one way to rewrite tangent in terms of cosine theta. Now remember, if it says in terms of, the only thing that can be in your answer is that one function. So we can't have sines or sines or secants or cosecants or anything like that. Okay, so that's one way to do it. The other way to do it over here is to look at this in terms of tangent and secant. So if we solve for tangent, we would have secant squared minus 1. Okay, and we're trying to get to cosine here, so remember that this is the same as 1 over cosine squared, like that. Okay, now before we take the square root, we should probably get a common denominator here, so let's go ahead and do that. So common denominator would be cosine squared over cosine squared. Okay, if I rewrite it like that. So I would have 1 minus cosine squared theta over the common denominator, cosine squared theta. Okay, so it's a good idea to get a common denominator anytime you have something mixed like that. And so now to get tangent by itself, we take the square root on both sides. So we've got tangent theta equals 1 minus cosine squared theta over cosine squared theta. All right, now remember we can break this up as square root over square root. I'm running out of space here. So if I do 1 minus cosine squared on top, and then on the bottom, I'm going to skip a step here. I would have square root of cosine squared on bottom, and we know square and square root cancel out, and I get cosine theta like that. Okay, so two different ways to do the same problem. This one took a few more steps, but maybe was a little bit more direct because you could see from the original problem that we could get to cosine, whereas this one you had to pull in another identity to get to the answer. But we get to the same exact answer either way. Sometimes when you do two different methods, the answers look a little bit different. They're in a different form. But you can generally get from one to the other if you do a little bit of work, like we had to get a common denominator here to get the right form of it. Okay, so that's the basic idea in getting an expression for one trig function in terms of another trig function. Look at the different versions that you have, the different identities, and see if you can get from one to the other. And if you go one way and it's not working, then maybe stop and go back and try a different method.